Good morning to all my students. First of all, I would like to say one thing. Subscribe my videos and click the bell icon. Subscribe and click the bell icon. You can tell your doubts, you can express your doubts in comment section. Comment section is there. Nearby video, comment section will be there. In comment section, you can express your doubts. You can tell your doubts. By that way, I will answer your questions or I will respond your doubts. 3 things I told. First thing is subscribe and click the bell icon. Click the bell icon nearby. Subscribe and click the bell icon. And you can tell your doubts in comment section. Therefore, I can answer your doubts. I can respond to your doubts. These are very important things. Now, coming to the point, probability is a great subject because if you learn probability or if you want to do the sums in probability, you must have been aware of trigonometry, matrix, algebra, sequences, geometry, calculus, statistics, all branches of maths. You must have been aware. All the fundamentals or just better, more than fundamentals will be in the applications, in the concept of probability, in the collection of problems in probability. Therefore, I choose this topic and you will get more questions in competitive exams, in all competitive exams. If you prepare for MSET, it will be easy for you for intermediate or 12th class. If you prepare for JEE, IIT, JEE mains, it will be easy for MSET. And afterwards, after 4-5 months, I will start advanced. Advanced coaching is different. Not now. First of all, you have to learn subject and what sort of collection of questions will be coming in JEE mains, in competitive exams. Up to the level of JEE mains, you have to learn first. Afterwards, you must learn, you must get yourself aware of advanced. That is the way. Not now. Now, regarding to the subject, non-occurrence of the event. Non-happening or the non-occurrence of the event. I have told you P of E bar. E bar. Probability of non-occurrence of the event, P of E bar. P of E bar means what? 1 minus P of E. P of E bar. E bar means equals to 1 minus P of E. That is the probability of non-occurrence, non-happening of the event. Similarly, the same idea is denoted by P of complement of E. P of complement of E. P of complement of E. E, right? In the place of power. In the place of power to the E, you write C, small c. That is complement of E. P of complement of E is nothing but P of E bar. Is nothing but P of E bar. P of E complement equals to 1 minus P of E only. Both are same. Because some student asked some doubts. Here, just I want to give you the oral idea of cards. About playing cards, I have given you. By the by, I have prepared some solutions to some important questions. I have done in my book. You please, after my lecture, please go through that. Please go through that after my lecture. Here, 3 cards are drawn from a well-shuffled pack of 52 cards. At random, what is the probability that the cards are all aces? Are all aces? Are all aces? So what is that? From well-shuffled pack of cards, 52 cards, 3 cards you have to, at random you have to take. 3 cards are drawn, 3 cards are drawn at random. Means, what is that? What is N of S? 52. 52, yes, 52 cards are there, no? 52C3, that is N of S. Because at random, we have drawn 3 cards from 52. So 52C3, first of all, please, everybody easily can understand it. N of S is 52C3. Once I told 52C3, how to write it? 3 is there, so 52, 51, 50. By 3 factorial, 3 into 2 into 1. Like that you have to write. For all that process only. 52C3 is N of S. Next, what is the probability, for what condition we have to find probability? All are aces. All are aces. How many aces are there? 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 Actually, how many aces are there? 4 suits. 4 suits. What is that suit? 13, 13, 13, 13. 13 diamond red, 13 heart red, 13 spade red, 13 spade black, 13 club black. First 2 red, spade and club black. All 13, all 4 suits. Among all these 4 suits, how many aces are there? So 13 out of 13, for every suit, 1 ace will be there. Ace, 4 aces will be there. How many we have to take? How many we have to draw? 3 cards. So 4C3 by 52C3. Why I am going to tell, please just for a while, please listen. After a while, you can easily understand it. 4C3 by 52C3. That is nothing but while drawing 3 cards randomly, probability that will be becoming aces, 3 aces. to become 3 S's, the probability will be 4C3 by 52C3. Now the important thing, for this only I have told all these things. Second question is, at least 1 is probability. Probability that at least 1 is. At least 1 is means here, whenever you are given at least 1 minus probability of no yes. 1 minus probability of no yes, you will get at least 1 yes. At least 1 yes. At least 1 yes means 1 yes, 2 yeses, 3 yeses, 4 yeses, like that. For that, the short way, 1 yes, 2 yeses, 3 yeses, 4 yeses. Why to say like this? Sometimes this is of course yes. Sometimes maybe another thing that will be more in number. So the shortest way is 1 minus no yes. Shortest way of the probability of no occurrence of yes, the probability of no selection of yes. 1 minus, then automatically you will get at least 1 yes. This is regarding this question. As an example, I am telling the same manner, in the same way, the same notion you have to apply in anywhere, anytime. At least 1. At least 1 yes means 1 minus at least 1 girl. At least 1 girl means there may be 100 girls. 1 girl for some occurrence, I think. 2 girls, 3 girls at least means. So, for that what we are going to do? 1 minus probability of the non-occurrence of that particular event. This notion you have to clearly understand. So here, now regarding to this particular question, at least 1 yes, probability of at least 1 yes equals to 1 minus probability of no yes occurrence. 1 minus no yes occurrence means yes occurrence 4. Total 52. 52 minus 4, 48. So 48 C3 by 52 C3. 48 C3 by 52 C3 is non-occurrence of yes. 1 minus probability of non-occurrence of yes will give us at least 1 yes occurrence. For that, what is the answer? 1 minus 48 C3 by 52 C3. This I particularly told with this idea, with this notion, you have to apply the same in any case. Another thing I want to tell you, here sets and relations, very important with regard to probability, because sets, more application in the operation of sets will be applicable, will be useful in doing sums of probability. Here, at least one of the events, A or B occurs. Event A or event B to occur. Or at least one of the events, For that you have to use A union B. First of all, you have to know this statement. The set of theoretic description you have to know. The theoretic description of the sets you have to know. Then automatically you can find probability. In what cases? At least one of the events given. At least one of the events A or B occurs. At least one of the events A or B. At least one of the events A or B occurs. Event A or event B to occur. Event A or event B to occur. You have to use the theoretic description of the set is A union B. To find probability P of A union B, you will write it. First of all, you have to know the set theoretic description. A union B. Both the events A and B occurs. Both the events A and B occurs. A intersection B. So you apply afterwards P of A intersection B. Neither A nor B occurs. Neither A nor B occurs. Carefully listen, I am slowly telling. Neither A nor B occurs. A bar intersection B bar. Or complement of A intersection complement of B. A bar intersection B bar. That is, neither A nor B occurs. Next, event A occurs and B does not occur. Event A occurs and B does not occur. A difference B. Exactly one of the events A or B occurs. Exactly one of the events A or B occurs. One of the events A or B occurs. A intersection B bar union A bar intersection B. What for this is? Exactly one of the events A or B occurs. Exactly one of the events A or B occurs equals to A intersection B bar union A bar intersection B. These are the fundamental things. Still more, but these are very, very fundamental. Basically, everybody must know this. Afterwards, while doing sums, all of a sudden, at a time, we should not teach. All you will forget. Few things learn. Remember few things strongly. Okay? So another thing is, here, today I have worked out some questions, some selective questions in my book, and I have taken video. You can go through them. In that purview, the question I like most from the playing cards, two cards are drawn at random. The same question I have discussed in my book, and you can see it in this video, but I am explaining again. 2 cards are drawn at random from a pack of 52 cards. So everybody knows that 52C2, that is NFS. That is not the problem. Now the problem comes. The probability of getting at least a spade and an ace. Here, the probability of getting at least a spade and an ace. At least a spade and an ace. For this, the number of selections of 1 spade, 1 ace from 3 aces. 1 spade. 13 spades are there, 13C1 into 3 aces are there, 3C1. Why sir 3 aces? 4 aces no, 4 suits no, 4 aces no. But we have taken 13C1. At least, what is the question? At least a spade and an ace. At least a spade. 13 spades are there. 13 spades are there. In that 13, out of those 13 spades, 1 spade ace will be there. 1 spade ace will be there. So, but I have taken 13C1. 13C1 means a spade ace or purely spade, spade ace or spade other also will be there. 13C1 means anyhow spade will be coming into 13C1 into. In the 13 spade ace will be there. No. How many aces will be left? 3 aces will be left. No. So therefore 3C1. So 13C1 into 3C1 plus another way. Selections of the ace of the spade and 1 other spade. So another way we can select 13 spades are there. No. 1 spade I want to take 1C1 and then 12C1 will be there. 13 spades will be there. No. I want 1 spade. So 1C1, spade separated, and 12 will be there. Out of 12, ace spade also there. Ace will be there, no? So that is 12C1 ace spade, ace, into 1C1 spade. So here, in the 2 cases, the same question I have discussed, don't worry. Please go through the video I have explained in my book. Please go through it. Besides it, I am explaining now. Here the question is at least a spade and an ace. Spade and an ace. Here, spade 13C1, 1 spade. Ace 3C1 into 3C1. Because in 13C1, there is ace in that pack. So, 4 aces will be there. 1 ace is included in 13. Therefore, 3 aces will be there. 3C1. This is one type of selection. Plus. Plus means R. Plus means R. Or otherwise, out of 13, I want to take 1 spade. No, 1C1. 1 spade I have taken. Purely 1 spade I have taken. Ace will be there. No, out of 12. In the 12, ace will be there. No. Ace spade will be there. No. That ace will be there. No. 12C1. Ace into spade. These are the 2 types of selections for at least a spade and an ace. This is very important logical question. Of course, total probability is logic. Here, the logic you have to understand. Again, you have to understand it. Okay. I have told you division of objects into groups. Division of objects into groups. Once I told division of objects into groups. For that I have given you one example. Fruit basket, apples, oranges, guavas. Total 4, 5, 4 means 4, 5, 9, 4, 13 factorial by 4 factorial, 5 factorial, 4 factorial, like that I told. Previous video. So here, division of object into groups. For this, I have given you, I have explained 5 rupee coins, 4 5 rupee coins, 2 rupee coins 3, and 2 1 rupee coins stacked together in a column. I explained in this video. In my notes, please go through it. Then the probability that the coins of the same denomination are consecutive. That please go through it on the basis of division of objects. I want to tell you binomial expansion also I explained in my book. By using binomial expansion, I have explained to you one question. 10 fair coins are tossed, then the probability of getting at least 5 heads. 10C5, 10C6, 10C7, 10C8, 10C9, 10C10. For that, how to simplify it, I explained it. Please go through that, go through the notes in this video. Please go through carefully and tell your comments or tell your doubts in the comment section nearby my video. It is very important. And subscribe, click the bell icon. Click the bell icon and subscribe my videos. Okay, see you in the next video. Let us meet. Please, without forgetting, go through the sums I have done in my book. Please go through it and learn more. Thank you. Dear students, please follow carefully. Binomial expansion. This can be useful or applicable in probability. 1 plus x whole power n, nc0 plus nc1x plus nc2x square plus so on plus ncn x power n. Put x equals to 1. 1 plus 1 in place of x. Like this. nc1 in place of x 1. So 1 only. nc2 1 square 1 only. nc0 plus nc1 plus nc2 plus so on plus ncn. So what is the result? 2 power n we can write in place of nc0, nc1 plus nc2 plus nc3 so on plus ncn. This is very, very important formula. In case x equals to minus 1, if you substitute x equal to minus 1, x equal to minus 1, 1 minus 1, 0. 1 minus 1, 0. 0 nc0 minus nc1 because minus 1. Minus 1 means minus nc1 minus 1 whole square plus nc2, like that it comes, so on, plus minus 1 power n ncn. So by this we can understand these NC0, NC2, NC4 we write this side, and NC1, NC3 that side we can send because this is 0. Add RHS both sides. Add RHS both sides. 2 into NC1 plus NC3 plus NC5 plus so on equals to 2 power n. So what is this? NC1 plus NC3 plus NC5 plus so on 2 power n by 2, 2 power n minus 1. Similarly, NC0 plus NC2, NC4 plus NC6 so on equals how much? Same 2 power n minus 1. This you have to remember. Some questions observe. 10 fair coins are tossed, then the probability of getting at least 5 heads. At least 5 heads. At least 5 heads means here n of E by n of S equals to 10C5 plus 10C6. At least 5 heads, no? 10 fair coins, so 5 heads, or 6 heads, or 7 heads, or 8 heads, 9 heads, 10 heads, like that. So 10C5 plus 10C6 plus 10C7 plus so on plus 10C10 whole by n of S. N of S is, once I told, 10 fair coins means 2 power 10. 2 power 10. 2 power 10 is 10 fair coins N of S. So like this. According to the binomial expansion you have learned, you see here 2 power n NC0 plus NC1 plus NC2 plus so on plus NCN 2 power 10 10C0 like that 10C10 and 10C5 I have taken plus 2 into 10C6 plus 10C7 plus 10C10. How it is? Because 10C5 is there. 10C5. 10C5 out of this I have taken. What will be here? 10C0, 10C1, 10C2, 10C3, 10C4, 10C5 I have taken, 10C6, 10C7, 10C8, 10C9, 10C10. But here 10C0, 10C0, 10C1, 10C2, plus so on, 10C10 is there? No. 10C5 I have taken. So how many will be there? 10C0, 10C1, 10C2, 10C4. 4 will be there. What is 10C0, 10C10 only? What is 10C1, 10C9 only? Because one formula is there, that is NCR equals to NCN minus R. NCR equals to NCN minus R. 10C0 equals to 10C10. 10C1 equals to 10C9. 10C2 equals to 10C8. 10C3 equals to 10C7. 10C4 equals to 10C6. So here 10C5 I have taken out. What will be remaining? 10C0, 10C1, 10C2, 10C3, 10C4. What is 10C4? 10C6. 10C6 is already there, so 2 10C6. What is 10C3? Here 10C3, 10C7. Already 10C7 is there, 2 10C7. And 10C2, there is 10C2 is nothing but 10C8. So 10C8 is there, already 2 10C8. 10C1 is 10C9. So already 10C9 is there, 2 10C9. 10C0 is 10C, 10 minus 0, 10C10. So 10C0, 10C10 both equal. So 10C10, how many? 2 10C10s. Like this, 10C5 plus 2 into 10C6 plus 10C7 plus 1, 10C10. Now I want to add 10C5 both sides. 10C5 both sides. If you add 10C5 this side, 2 10C5, so 2 common, 10C5, 10C6 plus so on, 10C10. Here we have added 10C5, 2 power 10 plus 10C5. Here 2 is there, that 2 will be coming here, that 2 will be coming here. 2 power 10 plus 10C5 by 2 equals to this only left, 10C5, 10C6 plus so on, 10C10. Because all will be happening because of this formula. In place of this, now enough E, at least 5 heads. 10C5, because 10 fair coins, at least 5 heads means, at least 5 means 6 heads, 7 heads, 8 heads, 9 heads, 10 heads. This is NFE. NFS you know very well, because 10 fair coins means NFS always 2 power 10. 2 power 10. 2 into 2 into 2 into 2 into like that. 10 times, so you have to write 2 power 10. Okay. So what is this? This is counted like this. This one. This one I have written here. By 1 by 2 power 10. So this is the answer. This is the answer, like this. So we can apply binomial expansions. Remember, the probability of getting or heads. In tossing unfair coins, the probability of getting or heads. In tossing unfair coins, NCR by 2 power n. Next, second question. 4 5 rupee coins, 3 2 rupee coins, and 2 1 rupee coins are stacked together in a column at random. Then the probability that the coins of the same denomination are consecutive. So 5 rupee coins 4, 5 rupee coins 4, 2 rupee coins 3, 2 rupee coins, 2 1 rupee coins, 5 rupee coins 4. What is NFS? NFS is 4 3 7 7 2 9. Total 9 factorial by 4 factorial 3 factorial and 2 factorial. So I have to like this. 9 factorial by 4 factorial, 3 factorial, 2 factorial. This is NFS. This is NFS. 9, total 9 coins. 4 5 rupee coins, 3 2 rupee coins, 2 1 rupee coins. For this I told once, in one basket, 5 apples, 7 oranges. Total how many fruits? 5 plus 7, 12 fruits. We can permute these 12 fruits as 12 factorial by 5 factorial into 7 factorial. This is called, I have given, division of objects into groups. M plus n Cm equals to m plus n factorial by m factorial n factorial. Total m plus n objects. M plus n factorial by separately m factorial, separately n factorial. This is called division of objects into groups. Same formula we have used here. That is why I have given this formula. And you observe here, m plus n plus p c cm. So this is another. This is also same formula. M plus n plus p is given. M plus n plus p is given. Total things, objects. So permuted m plus n plus p factorial by m factorial n factorial p factorial. What is this? Division of objects into groups. Division of objects into groups. Division of objects into groups. Remember this formula. Here, number of ways to distribute m plus n plus p items. We have to distribute apple fruits, orange fruits, guava fruits, like that. Items among 3 persons. Okay, then number of ways to distribute is m plus n plus p factorial by m factorial n factorial p factorial into 3 factorial. This is our formula from permutations and combinations, division of objects into groups. Remember. Same we have applied here. 9 coins, 5 rupee coins, 9 coins, 5 rupee coins 4, 2 rupees coins 3, 1 rupee coin 2. Distribute into groups, NFS. Now, the probability that the coins of the same denomination, you have to find probability for what? The coins of the same denomination are consecutive. Now N of E. The probability that the coins of the same denomination are consecutive. Same denomination are consecutive. Same denomination are consecutive. Same denomination or consecutive means here it is same denomination you have to take. 2 1 rupee, 2 rupees, 2 5 rupees, like that. Then what will be? It is counted as 3 groups. 5 rupee coins and as a 1 unit, as 1 group, 2 rupees coins as 1 group, 1 rupee coin as 1 group. So these 3 units can be taken N of E 3 factorial. N of E 3 factorial. Because the denomination must be the same denomination. As the same denomination, so 3 units, 3 factorial. Now, P of E equals to N of E by N of S. N of E is 3 factorial. N of E is 3 factorial whole by N of S 9 factorial by this much and 9 factorial by this much. This has gone up. So here the answer is 3 factorial into 4 factorial, 3 factorial, 2 factorial by 9 factorial. If you calculate, you will get 1 by 210. About chords, I have told already, but I am focusing on chords. I have written in my book, well shuffled deck of 52 chords. All chords are divided into 4 suits. There are 2 black suits, spades and clubs, and 2 red suits, hearts and diamonds. In each suit, 13 chords, including, I have written in sector, yes, A, yes, A, C, E. 2, 3, 4, 5, 6, 7, 8, 9, 10. J, Q, K. J is jacks. Q, queen. K, king. Out of 52 chords, 12 of these face chords. What are the face chords? J, Q, K of all 4 suits. J, Q, K, J, Q, K, J, Q, K, J, Q, K, 4 into 3, hence 12. So, out of 52 chords, 12 of these face chords. J is jocks, Q is queen, K is king. Hence, the probability of face chords 12 by 52. N of E is 12, N of S is 52. 12 by 52, almost 23% face chords probability. I have written here 52 chords, 52 chords, observe. 13 heart, 13 diamond, both are in red color. 13 spade, 13 club, both are in black color. 13 heart is one suit, 13 diamond is second suit, 13 spade is third suit, 13 club is fourth suit, 4 suits. Heart and diamond in red color and spade and club is in black color. Now let us come to the question. Two cards are drawn at random from a pack of 52 cards. So NFS is 52C2 because you have to take at random 2 cards 52C2. NFS is NFS is got. Next, the condition. The probability of getting at least a spade and an ace. At least a spade and an ace. At least a spade and an ace. This can be the number of selections of one spade, one ace from three aces. The number of selections of one spade, one ace from three aces. Here, how many spades are there? 13 spades. 13C1. 13C1. 13 spades are there. 13C1. But here I am not taking spade ace. I am not taking spade ace. 13C1 spade I have taken. Next, how many aces are there? Everywhere. Here, one ace will be there, like this. One ace here, one ace here, one ace here, one ace here, one ace here will be there. Four aces will be there. Four aces will be there. But I have taken here the number of selections of one spade, one ace from three aces. One ace from three aces. Three aces means, what is the three aces here? Because out of four aces, here one ace is there. I am not taking from this. So I left this. How many aces will be there totally? 3 aces. Out of 3 aces, I selected one ace. Here, 13 spades, I have selected one spade. So, that is why the number of selections of one spade, one ace from 3 aces. R means, what is R? R means plus. R means plus. Selections of the ace, of the spade, selections of the ace of the spade. So here, and one other spade. Here, spade, 1C1 spade. And then out of 13, 1C1 I have taken spade, so 12 will be there. In this 12, ace also will be there. So that ace spade here, that is given here. All selections of the ace of the spade, ace of the spade, ace of the spade, and one other spade. This is very important logic. You have to understand. Observe this question and understand. Observe this question. Observe this question. Observe this question. And understand. At least a spade and an ace. At least a spade at least a spade and an ace. 52 C2, the number of selections of one spade, one ace from three aces. That is given here. That is given here. Or means plus selections of the ace of the spade, the ace of the spade, and one other spade. So totally the answer is, if you calculate like this. Next, if the letters of the word attempt are written down at random, immediately you take n of s is 7 factorial by 3 factorial, because divide into groups. I told how attempt, you see here 1, 2, 3, 4, 5, 6, 7. 7 factorial by group 1, 2, 3. 3 t's. So n of s is 7 factorial by 3 factorial. What is n of e? Here, random. The chance that all t's are consecutive. The chance all t's are consecutive. The chance that all t's are consecutive. Here, all t's 1, 2, 3. 3 t's as 1 unit. As 1 unit, 3 t's are 1 unit. 1, 2, 3, 4. 4 plus 1, 5 units. So that is 5 factorial. Because the chance all t's are consecutive. All t's are consecutive. All t's are consecutive means here all t's, if you take as 1 unit, if you permute them, then anywhere it will be any letter of after A, after M, after P, after E. Those the bundle of T, the bundle of 3 T's, 3 T's as a unit, as a bundle, as a group I have taken. No, that one will be arranged. So A, E, M, P 4 units, 3 T's as 1 unit, total 5 units. N of E is 5 factorial. So now, according to his condition, what is his condition? All t's are consecutive. Since in a single cast with 2 dice, the odds against drawing 7 is Question is, in a single cast with two dice, in a single cast with two dice, means two dice if you throw one time, the odds against drawing 7 is, once I told here, odds in favor of P of E by P of E bar. Odds against P of E bar by P of E. Once we discussed this one, firstly we discussed, just first video or second video, we discussed this. I think this is 5th or 4th video. So here, P of E bar by P of E, odds against. Odds in favor of P of E by P of E bar. First of all, we have to find probability of drawing 7. N of S is 6 square because two dice thrown, once I told before this, 6 square. And E, the event for the probability is drawing 7. Two dice, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. So totally, how many number of E? 6. 1, 2, 3, 4, 5, 6. Total 7. Total should be 7, no? 1, 6, 7, 2, 5, 7, 3, 4, 7, like that. So how many items? N of E is 6. P of E equal to N of E by N of S. What is N of S? 6 square. So 6 by 6 square, 1 by 6. And also P of E bar, how to find P of E bar? P of E bar equals to 1 minus 1 by 6 is 5 by 6. That's all. It is very direct question. So hence odds against drawing 7 equals to formula P of E bar by P of E. That is 5 by 6 by 1 by 6. 5 is to 1. See this question from the matrix. Once I told from all branches of mathematics, probability questions are prepared. A determinant of the second order matrix is made with the elements 0 and 1. Again I am telling, a determinant of the second order matrix is made with the elements 0 and 1. Which of the following is R to A? Probability of that 0, 5 by 8. It's right. Probability of that greater than 0, 3 by 16. Right. Probability of that is non-negative. Non-negative means all positive and zeros. Probability of that equal to 0 and probability of that is positive considered as non-negative equals to 13 by 16. Right. These A, B, C, more than one option, right options. Last D, none of these, it is a wrong answer. So determinant of the Again, see the question. The determinant of the second order matrix is made with the elements 0 and 1. You prepare the determinant of second order matrix with the elements 0 and 1. Okay, let's go to the solution. I have written by using 2 by 2 matrix determinant. He has given in the question 0 and 1. Either 0 or 1 I can use and prepare the determinants. 0 0 0 0 4 zeros, 1 0 0 0, like this. Observe. I have written observe, 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 observe it, observe, observe, observe. So here total 16 determinants I have prepared, I have made by using either 0 or 1 in the element places, like this. The delta determinant is 2 by 2 determinant is 4 boxes I have given. Each box can be filled in 2 ways, 0 or 1. Okay. Boxes are standard, ways are variable. So 4 boxes standard. So 4 to the power 2. 4 square, that is n of s. N of s. Here 4 square is n of s. That is 16. I have shown you. Practically I have written for the satisfaction how many deaths by using either 0 or 1, 16 death forms I got by using either 0 or 1 in the places of elements. So I am not telling you to write like this to waste your time in competitive exams. I am telling you like this, 4 boxes are there. These 4 boxes are standard. It will not be moving, but the moving are 2, either 0 or 1. So the moving please keep in the power 4 to the power 2. The moving always in the place of power 4 square, that is 16. So n of s how much? 16. Now that less than 0. That less than 0 means we can easily tell. We can easily pick up like this. This is that less than 0. That less than 0. 0 1 1 0. 0 minus 1 minus 1. 0 minus 1 minus 1. 0 minus 1 minus 1 less than 0 3. Automatically greater than 0 also 3. So what is the probability? 3 by 16, 3 by 4 square. And greater than 0 also 3 by 16. Greater than 0 also 3 by 16. P of E also 3 by 16 for greater than 0. For that greater than 0 also 3 by 16. And negative 3 by 16. Debt less than 0, probability 3 by 16. Debt greater than 0, probability 3 by 16. Total how many? 16 debts. 3 negatives, 3 positives. Total 6. If you remove 6 from 16, how many will be? 10. That what is 10? The 10 is, if debt 0, then P of E equals to 10 by 16, because positive 3 debts, negative 3 debts, total 6 debts, entire exhaust to 16. So 16 minus 6, 10 will be there. So 10 by 16 is debt 0. Debt equal to 0 debts. 10 by 16 is 5 by 8. So what is the answer? The answer is, here I have written, exclude 3 plus 3, 6. 6 debts remaining, 10 debts are there. So the answer is debt 0, 5 by 8. 5 by 8 means 10 by 16. Next, debt greater than 0, 3 by 16. Debt is non-negative. Non-negative means what? Only 3 cases negative you have to remove. And out of 16, 3 remove. 13 by 16, 4 square. That is non-negative. So that is non-negative 13 by 16. And B is right and A is right. ABC right.